Okay, so we want to graph y equals log base 2 of x. But I will get started with y equals 2 to the power of x, just because it's a little bit easier to understand first, and I will make the changes so that we can arrive at y equals log base 2 of x. So, I will just draw a small table of values here, just so that it makes sense to everyone. I'll plug in maybe -2, -1, 0, 1, 2, and 3 for x. So if I plug in -2 for x, 2 to the power of -2 is a quarter. If I plug in -1, we get 2 to the -1 half. If I plug in 0, we're going to get 1. 2 to the 1, if I plug in 1 for x, we're going to get 2. If I plug in 2, we're going to get 4. And 2 to the 3 is 8. Great. So now we have a bunch of points to work with. And so x is -2, y is a quarter. So note, of course, that each one of these combinations is a point. The next one is -1 and half. Then we have 0 and 1. Then 1 and 2. 2 and 4. 3 and 8. Look at that. Okay, so now I'm just gonna draw like basically a straight line here, just because it's gonna be an asymptote. We're gonna talk about that in a second. It gets very close to 0, but it never actually reaches 0. And then here, the graph just takes off because it's exponential. Okay, so this I like to call this the Superman run, because it looks like he's running, then he takes flight. And so how does this relate to log base 2 of x? So why did I draw y equals 2 to the power of x first? Well, because these are inverses of each other. So if I draw a line right here, the y equals x line, and I reflect our, this is, hold on, this is y equals 2 to the power of x. So if I reflect y equals 2 to the power of x onto the y equals x line, which is the line that I just drew, we're going to obtain y equals log base 2 of x. So let's do that. So each point just becomes the inverse. For example, -2 and a quarter becomes a quarter and -2. -1 and half becomes half and -1. 0 and 1 becomes 1 and 0. 1 and 2 becomes 2 and 1. So I'm just inverting the points. Hope that makes sense to everyone. This is 2, 4 becomes 4, 2, and 3, 8 becomes 8, 3. Okay, and then of course we also, it's kind of like a Superman run from the Bizarro world. Okay, so the blue line here, well, I wish that was a little bit smoother over there. The rest wasn't too bad. This is y equals log base 2 of x. Okay, so now let's just talk about some properties here that we have for these graphs. The first one that I'd like to point out is the asymptote for the exponential function. And the asymptote for the exponential function in this case is just going to be y equals 0, just this line right here, which is the x-axis. So the asymptote is just y equals 0, but for the log function is actually just, actually let me pick a different color, a lighter color. Here we go. The asymptote will be just x equals 0. Basically because we can't even plug in 0 for x. It just doesn't happen. So that's it. For the following graphs, we're just going to make transformations and shift basic log graphs around. And I hope this made sense to you. And good luck with log.